So we've been talking about complex numbers. Now we need to look at some different operations that we can do with our complex numbers. We can add, subtract, multiply, and divide our complex numbers. When we're looking at them, we need to keep in mind that we have both the real and imaginary part, because that's going to be important. When we're adding or subtracting, we're going to look at our real parts and our imaginary parts. And we're going to combine those two parts together like we would our like terms. So notice that we have a 5 and a 2, and we're adding them. So we would do 5 plus 2. Then we have a -7 and a 4. And that is what's going to be in front of our I. So 5 plus 2 gives us 7. And then -7 plus 4 gives us a -3i. Now I wrote out that second step just to kind of let us know where I was getting the numbers from. However, you don't always have to write it out like that. You can simplify it kind of just to that next step. So for subtraction, it's going to be very similar, except now we are subtracting instead of adding. So again, looking at our real parts, which is going to be 4 and 3, and our imaginary part, which is going to be -8i and -6i. And again, combining those. So we will have 4 minus 3, and then a -8 minus a -6 times I. So 4 minus 3 gives us 1. And then we have -8 minus -6. So that would become a +6. So -8 plus 6 gives us -2. And then we need to add our I. And so that would be our answer. And that would be how any of our addition or subtraction is going to work. Now with our multiplication, it's going to be very similar to when we just have a multiplication with our x's. So you're going to need to multiply it out. Many of you are used to the term FOILing, which is fine as long as we know what the process is. So we need to do 2 times 9 and 2 times -3. Then we also need to do 4i times 9 and 4i times -3i. The difference is going to be when we start trying to simplify. So let's write those out. 2 times 9 gives us 18. 2 times a -3i gives us -6i. 4i times 9 gives us +36i. And then 4i times -3i gives us -12i squared. Then we just want to combine any of our like terms. So notice that I just have an 18, and it does not have any like terms, so I just have 18. Then notice that our -6i plus 36i, they both just have one I, so we can simplify those to be plus 30i. Now, our I squared doesn't have any common terms. However, we do need to simplify it, because remember from the previous video that we know what I squared equals. It equals -1. So we don't want to leave it as I squared. We want to simplify it. So now we have 18 plus 30i plus 12, because -12 times -1 gives us +12. And now we can simplify our 18 and our 12. So 18 plus 12 gives us 30. So we get 30 plus 30i, and that would be our final answer. So on our next one, we're going to do the same thing. So we're going to do 2 times 3, which gives us 6. 2 times -2i is going to give us -4i. -4i times 3 is -12i. And -4i times -2i is going to be +8i squared. Again, combining our common terms, I have a negative 4i and a negative 12i, which is going to give me negative 16i. We have an I squared, so we need to replace that with a negative 1. So we get 6 minus 16i minus 8. So we get negative 2 minus 16i as our final answer. Alright, so lastly we have division. And we can't just do division like we normally would when we have a division with complex numbers. What we actually have to do is kind of a form of multiplication. So if I have a number that looks like a plus bi, the complex conjugate would be a minus bi. So basically all we're doing is we're flipping that middle sign. And that's what we're going to need to multiply both the top and the bottom by. So notice in this one we have 3 plus 6i. So our complex conjugate is going to be 3 minus 6i. I'm just flipping that middle symbol. And we need to multiply that to the top and the bottom. Because now notice that technically I'm multiplying by 1. So I'm not changing the value of my expression, I'm just changing what it looks like. So then we're just going to multiply it out. Well, I have a monomial times a binomial, so we can really just think about that like distributing. So we would have 2i times 3 is going to give us 6i. Then we have 2i times negative 6i is going to give us negative 12i squared. And now watch what happens when we when we multiply out our denominator. So 3 times 3 gives us 9. 3 times negative 6i gives us negative 18i. 6i times 3 gives us a positive 18i. And then 6i times negative 6i is a negative 36i squared. So notice that there in the middle, our positive 18i and our negative 18i are going to reduce to 0. So that means that we're only left with our 9 minus 36i squared. But remember that we don't want to leave any I squareds there. So we're going to need to replace the I on the top, the I squared on the top and on the bottom with a negative 1. So now we're going to have 6i plus 12 on top and 9 plus 36 on bottom. So then just rewriting, because remember that we want our imaginary part to come second. So I'm just going to change the order on top. And then we just want to simplify. 9 plus 36 is what we have on bottom. So that's going to give us 54. Now we could either leave our expression like that. However, notice that we still technically have a fraction bar there, and so we don't really want that. And so what we can do now is notice we only have one thing in our denominator, so we can separate this out into two separate fractions. So we would have 12 divided by 54 plus 6 divided by 54i. And then we just want to simplify our fraction. So notice that for our 12 and 54, we want to look for the greatest common factor that we can reduce those by. So which is going to be 6. So 6 goes into 12 2 times, and into 54 9 times. And then 6 goes into itself 1 time, and into 54 9 times. So our answer would be 2/9 plus 1/9 I. Now be careful, because we can't combine our 2/9 and our 1/9, because our 1/9 has an I and our 2/9 does not. So that's as simple as we can write it. We have our real part and our imaginary part.